Hello and welcome to CodeVichar. So in today's video, we are going to solve a very interesting problem, maximum number that sum of all the prices is less than or equals to k. So in this problem, we are given an integer k and another integer x, and we have to find the greatest integer num such that the price of all the numbers from 1 to num is less than or equals to k. And let us now look at how the price of a particular number is calculated. So price of a particular number is nothing but the number of set weights at positions I such that I is a multiple of x. I is a multiple of x. So let us understand this problem well using an example. So here we are given k equals to 7 and x equals to 2. So let us take a range of numbers from 0 to 15 and 1, and then we are representing them in their binary representations. And one thing to note is that the indexing is done from right to left. Okay. So one condition we have studied that the price of a particular number is the number of set bits at position I that are multiple of x. So here x is 2. So only column bit 2 and bit 4 will matter to us. Bit 3 and bit 1 will not matter to us, like this. Only three these columns will which are multiple of x can contribute to the price. Another column will not contribute. So let us calculate the price of each number corresponding to them. Like here it is not k, it should be price. So let us check for any random number. Like here it is 1 and it is 0. So sum of all the price of 9 is 1. Here like here it is 44 14, it is 1 1. So its price is 2. So in this way we have calculated price of every number. But the task is that we have to check the number such that the price of all the numbers from 1 to that number should be less than or equals to k. So for that we have to calculate the cumulative frequency of the prices, like the cumulative price we have to find, and we have to check the largest number which is satisfying that k whose sum is should be less than or equals to 7. Like if we see here, 2 is less than 7, 3 is less than 7, 4 is less than 7. So the largest number whose price is less than or equals to 7 is nothing but this, is nothing but 9. So the largest number which is satisfying the condition is nothing but the number is 9. So 9 will be our answer. So one brute force way to do this problem can be we can start iterating from the number 1, then 2, then 3, 4, and side by side calculating their prices and summing up all of them. And then we will check whether the sum of prices should be less than or equals to 7 or not, which is should be less than or equals to k or not. So we will move up to the number such that the price is less than or equals to k. And when this condition is not satisfied, then we can return that number, that this is the greatest number that is satisfying the condition given. Okay, but it will be very time consuming as we are given higher constraints. So to solve this in an optimal way, we will use binary search. So in binary search, we will have two pointers, and a start pointer and end pointer, pointing to the endpoints of the range we are considering. So then we will check whether the particular number mid is satisfying the condition or not. If it is satisfying, then we will move the start pointer to the next position of the mid. And if it is not satisfying, then it is obvious that the answer will lie in the first half, not in the second half. So we will reduce end to the mid minus 1 position, like here. So what we are doing, we have taken two variables, start and end, and we are proceeding with the binary search approach. Then we have calculated the mid value, and we have also taken a price variable which will store the price of particular element, which is here mid, and the length variable will store the length of the binary representation of number mid. Okay, and now what we are doing, we are iterating over all the columns which are multiple of x, because only those columns can contribute to our answer. Other columns will not contribute. Other positions will not contribute. So the contribution function will return the number of bits which are set bits, the number of bits which are set bits from the numbers ranging from 1 to the number mid. Okay, and how it is doing, we will see that in the further part of this video. So for now, think that this function will give us the count of set bits at a particular position in numbers ranging from 1 to mid. So we will check for every column which are multiple of 2, and in this way we can get the price of the particular number. And now we will check whether the price of this particular number, whether the total price, it is total price, okay, total price from 1 to n, whether total price of the number from 1 to n is less than or equals to k. If it is less than or equals to k, then the answer can be that the mid itself, or the number or the high number also. Okay, so what we are doing, we are moving to the next half, And if it is not satisfying, that means mate is not that number, it is higher number which is not satisfying. So we will move to the first half of the split. Okay, so in this way, using this binary search approach, the answer variable will store the valid number, will store the largest number, which will satisfy our answer, and it will be our answer. Let us now look how this contribution function will work. So let us now look at the contribution function. So in this function, the second parameter is position, like which is representing the column number, and the first parameter is the number itself, up to which we have to find the price. Now, what we have done, we have calculated the cycle length first using the formula. Then we are calculating the complete cycles that exist up to num. Like there can be num 1, 2, 3, 4, and so on up to num, and there can exist multiple cycles there. Multiple cycles can exist, but we are interested to find the complete cycles up to num, which can be calculated by num by cycle length. And the total number of set bits up to num can be calculated by the number of set bits in every cycle into the number of cycles. Okay, and in every cycles there are half the number of zeros and half the number of ones. So number of ones in a single cycle can be given by cycle length by 2. In a single cycle, the number of set bits are cycle length by 2, and there are a total of complete cycles. So if we multiply them, we can get the total set bits. But there is one more thing, like we have calculated up to the complete cycles, but there may exist another cycle which is not completed yet but has started. So we will calculate the remaining length using num mod cycle length. And as we know that if we consider a cycle of length 8, then it will look like this. Okay, it will look like this. So first half will contain zeros and the second half will contain ones. So if the remaining length, like it is cycle length. Okay, if so, what we will do? So we will do what? We will check whether the remaining length is greater than or equals to cycle length by 2 or not. If it is yes, then we will ignore the first half, obviously. So we will subtracting the first half. And why we are adding one? We are adding one because the cycle has started from the num 0. Num 0 is the like this, because the cycle has started from the num 0, and num 0 is the first element, and num 1 is actually a second element. Okay, so that's why we are we are kya? So that's why we are adding 1 to our total set bits, because there's a bias of 1 because of 0. So in this way we can get the total set bits in a particular column up to number num. So this is the exact code I have explained. Now if we submit the solution, yes, it is accepted. So that's all in this video, and don't forget to like and subscribe to CodeVichar if you like this video. Thank you.